Hello one and all, welcome to another processing tutorial. This is for the Leo Triplet, taken from my Portal 8 City Centre back garden. Use my ASCAR 130 PHQ telescope and ZWO 2600 MC Pro colour camera. It's 21 hours of integration time, and I used an Optolong L-Quad Enhance filter. It's a broadband filter, so it's quite useful for light pollution. I also find that particular filter is good for letting hydrogen alpha through, so that is useful for capturing hydrogen-rich areas of galaxies. So we're going to edit this up. Because it's just one filter, it shouldn't take too long. It shouldn't be that complicated. So let's crack on with it. First thing I'm going to do here is just make a clone of this image so we can go back to it if we mess anything up. There we go. And now I'm going to run a SETI Astro script called Automatic DBE, which should help to remove those background gradients. Now that's done, we can do an unlinked screen transfer function and we can see the gradient that was removed. Don't need that though. This is the image. There we go, it's done a pretty good job of that. So we don't need that one. This is the one that we're going to continue working on. Let's run image solver on this. Sorry, here it is. Image solver will just give PixInsight some extra info about the image that will be useful later. The next stage is to run Blur Exterminator. You can use automatic PSF. I find for this quality of data, I actually have a bit more luck if I use this free plugin called PSF Image Creator, which I use to evaluate, and that will calculate the PSF, the point spread function of the stars. And once that's done, we want to find the two full width half maximum values, the x and the y, and halfway between those would be 2.75. I'm going to remember that, 2.75, and that's what we're going to put in here, 2.75. I leave everything else on the defaults, and then run that on the main image. If you're zoomed out, you don't really see much difference, but if you zoom in, you can, if I do go back like before and after, I don't know how well that shows up on YouTube, but it sharpens it quite a lot. Quite effective, that is, Blur Exterminator. Right, next we need to use a preview to find just a bit of blank background, which is going to be our useful for the next stage, which is color calibration. Now I've got some profiles preloaded here. This one is for my L-Quad Enhance. Background utilization, region of interest is what we just selected. And this should help sort our colors out. Right, looking good. And then next stage is to stretch the data, and I like to use multi-scale adaptive stretch for that. I'm going to take off the temporary stretch, the screen transfer function stretch there, and then click on the circle to have a little preview. We have a background reference, which is what we've already chosen there, the preview. And for now, let's just leave that at the defaults, but you might want to play about with it more. All right, once that's done, we're going to close that, and we don't need that preview bit anymore, and I think we should make a clone of that. So we're going to call that MAS, multi-scale adaptive stretch, make a clone in case we mess anything up. All right, now I often make a separate starless image to work on the backgrounds, but for this particular target, this kind of the glowing areas around the galaxies, around this one and M66 here in particular, make that a bit tricky. So I'm going to try and do all of this on just one image. So curves, adjustment. Let's take the background down and boost our galaxies a bit. Click on the circle here for before and after. A lot better. We can do multiple rounds of stretches. And I can see we've still got, there's a bit of green splodginess there, which I would like to take out. So let me think. All right, I think we will actually have to create a mask so that we can reduce the saturation of the background but not affect the galaxies and the stars so much. Okay, no problem. So range selection, real-time preview. Let's change our limit and our smoothness so that we have the background selected. That's not bad actually, as we've got there. Okay, let's apply that. And this mask is going to allow us to just work on a particular part of the image. All right, so I'm going to apply that mask. But we don't need to see all the red, so let's click on the little magnifying glass up there so that we don't see it. And I always forget if I get it the right way around or not. I might have to invert the mask. Curves transformation. Yeah, at the moment I've got the galaxies with the stars selected. Whoops, right. So invert the mask. Let's take the background down a little bit. And then, main thing I want to do here actually is color saturation. And I'm going to take all the saturation down. And then the green splodginess that you sometimes get with OSE cameras shouldn't be as apparent. Makes a bit of difference. Let's sharpen the galaxies a little bit next. So to do that, let's flip the mask again so that we've just got our galaxies and our stars selected, not the background. Bit of unsharp mask. Let's zoom in so we get a closer look. The default setting of 0.8 is way too much, but we can boost it a bit. Go to 0.45, I think. Sharpen, sharpen. To run that, you don't click the square, you drag the triangle. Looking good, looking good. Right, I think it is time for a little bit of noise exterminator. Quite a bit, 0.7. It's quite aggressive because there is a fair bit of noise still in this image, despite there being 21 hours of integration. Let's see, has that smoothed things out a bit? Oh, silly me. Still got the mask applied. Remove the mask. And let's do that again. I wonder if you spotted that mistake. Well done if you did. Because we were only applying noise exterminator to the area where we had the mask applied. But we want to apply it to the whole image. So let's do that again. There we go. Let's have a look. That smoothed it out quite a lot. Good job, noise exterminator. I think that's on the cusp of being too much. You don't want to get rid of all your noise because our brains interpret some noise as sharpness. If you get rid of all the noise, then it looks a bit plasticky. But I think that's all right for now. Let's do a little play about again with the curves. Try and really get these galaxies to pop. And darken the background. Oh, I might have made the background a bit too dark. Thing is, I do have this slight gradient still, don't I? So a darker background might mask that sin in this instance. And I reckon we're not too far off. I might play about with the stars a little bit. By using the star reduction method here. This is a free plugin by Bill Blanchard and Mike Cranfeld, I think. So let's remove the stars here. And then with that done, star reduction method 3v3 I find is quite good, so I'm going to use that on this. And that should have tightened the stars a little bit before and after. Yeah, that looks pretty good. And stars are a little bit crunchy. So a tip that I've picked up from a kind user on the Stargazers Lounge is that what you can do is go to resample. Algorithm by cubic here, L-Quad mass, and reduce by 50%, and then upscale by 200%. In some instances, and it often works for my data, the core objects that you're trying to image, like the galaxies, will still look fine, and it kind of smooths out any crunchy stars. Right, I think I'm going to leave that there for now. You kind of get the idea. Carry on playing with it if you're trying to follow along. Do some more masking if you like. Try and get a little bit more detail out in those galaxies. I think there is more detail that can be teased out. But for now, for the sake of trying to keep this video brief, those are the main steps that I've taken. I hope that was useful. Thank you very much, and I'll see you for the next video.